Hello everybody. As we all know, knowledge of materials plays a very important role in semiconductor industry. So, it pays to know their characteristics. The objective of our project is to realize these characteristics at reduced cost.
So this is the PCB of our entire circuit. It is divided into a high voltage part and the other one is low voltage part. So the high voltage part circuit consists of a transformer, inductor, and if you can see here, you have the rectifier circuit here, and you have the entire LC filter part. And the low voltage part consists of a part of the programmable voltage circuit, then a current circuit, and the microcontroller circuit.
We have used microcontroller that supports 8051. MSP430 can be used, which has much more flexible instruction set, but we couldn't use because of downloading problems.
The programmable voltage circuit contains this stack. So the input to this stack is from this microcontroller. So through this microcontroller, a code is written in which the inputs are given to the ports by the user. Through the port, the input is provided to the DAC. So the DAC output is the current, so which is converted into voltage by using this LF356 op amp. Then the output of which is provided to the
OPA 140, which is TIIC for amplification. Then to
LM311 comparator. So here it compares two signals. One is the signal coming out of DAC and the other signal is a very high voltage. So it is limited to 32 volts by using this Zener diode, 32 volt Zener diode. Next you have two DACs over here. So one is the current control DAC and the other one is the current range DAC. So the current range DAC is used to provide the maximum value of the current, and the current control DAC is used to vary the range.
the GUI for entering current and voltage values is as shown. It has two modes, voltage and current mode. Data is to be sent serially using COM1 using 9600 baud, standard baud, and then ports are to be open to begin communication. The voltage values, that is minimum to maximum with the step increments, is entered. The current remains constant in voltage mode. All the above parameters are stored in the microcontroller. And when the start button is pressed, the inputs are sent, manipulated, and then sent to the DACs to control current and voltage. Similarly, in the current mode,
so for example, let us say the maximum current value is maintained at 16 milliamps and we are providing a present value in the GUI as we explained before as 1 milliamps. So from 1 milliamps to 16 milliamps it is varied in steps. So you can see that the voltage is varying here. So for the varying inputs, so this is the voltage output that we are getting, and the current output is
this is a whole setup. The GUI is used to send data serially to the microcontroller, which then sends it to the DAC. The power supplies power the IC. Thus, the voltage and the current across a sample can be varied in step ramp. This is a sample we wanted to test, which we obtained from the chemical department of a college using DSO. DSO is a storage oscilloscope with a multimeter in it. It provides both the IV plots and the switching time graphs. An example of the plots is as shown.